All right, so this is part 3 of our lesson on reviewing graphing rational functions. In this video, we're going to keep going, practicing finding the holes, the vertical asymptote, horizontal asymptote, slant asymptote, domain, y-intercept, and x-intercept without graphing. We should be able to do all those things without actually graphing these functions. So let's zoom in on number 4. Okay, so here's number 4. Actually, I like to find the horizontal asymptote first. Before I start canceling things out and stuff like that, let's find that horizontal asymptote. Is there a horizontal asymptote for this problem?
Yes.
How do I know? How do they work again?
Because the top degree is not.
The exponents, the degree, okay? How do the degrees compare on this one?
The top one is smaller than the bottom.
The top, the numerator degree is less, okay? Degree 1, degree 2. So what's the y-intercept, what's the horizontal asymptote when the top degree is less?
Y equals 0.
That's when it's y equals 0, all right? So this is a y equals 0 situation. I just have to look up at the columns. All right, so third column. So y equals 0 is my horizontal asymptote. Okay? That means there won't be any slant asymptote because you can't have both. So slant asymptote, none. Okay, now let's talk about holes and vertical asymptote. Okay. When are there holes? Where do holes come from? When do they happen? So correct. When factors cancel out, that's when you get holes in the graph. So to see that, you need to factor some stuff. So let's factor out this denominator and see if anything cancels out. How does this factor?
X plus 7,
X plus 7, x minus 3. So is anything going to cancel out?
No.
No. So that means there won't be any holes. None. So that means both of these factors are going to give me a vertical asymptote, correct?
Yes.
So what are my vertical asymptotes?
7 is positive.
X equals negative 7.
X has 3.
X equals positive 3. Make sure you say the x equals part. If you just say vertical asymptote, negative 7, you're losing a point. Put it on my desk. Terp. Okay, so we got vertical asymptote, horizontal asymptote, slant asymptote. Okay, that brings me up to the domain. Now, we should be able to do the domain just from the vertical asymptotes. Okay, just from the vertical asymptotes without an actual graph. So just remember this: we have the negative 7 and 3. So let's do it this way. See, negative 7 and 3. All right, so I'm trying to do the domain right now. Now, imagine a number line will help us. If we have a number line, I'll put it over here. If we have a number line, we have an asymptote at negative 7, and we have an asymptote at 3. Okay, that will be 2 breaks in the domain. So that means we're going to have 3 zones, 3 parts to our domain, one in each part of these, in each one of these zones. So the first part of my domain is going to be from here, like this left part over here. So what's that part of the domain going to be? Read it to me.
Infinity, negative.
Negative infinity to 7. Okay, union. Let me switch colors real quick.
Negative 7.
Yeah, I was about to put it.
Just remind me.
Ugh. You're being helpful, not hurtful. I appreciate that. Wait, so negative 7, union. Okay, and then we got this part in the middle. So what's that going to be? Negative 7 to 3. Okay, union. And then, correct, we have this portion on the end. So that's going to be 3 to infinity. So notice we don't need we don't need a graph to be able to do this. We can just do it from the vertical asymptotes. If there was a hole, you would use the hole in the same way to break up the domain. Holes count as a break in the domain. Okay? So I think I saw a question. All right, so time for the y-intercept. If I want the y-intercept, I let x equal 0. So if I let x equal 0, that means I'm just going to put in zeros everywhere. Okay? Really, going back to the original function for a second. If I let x equal 0, that means this term is gone, that term is gone, and that term is gone. So really, it's just going to be the constants every single time. So 1 over negative 21. And leave it like that, negative 1 over 21. Okay, this is my y-intercept, so I'm going to put that as my y value, negative 1 over 21. Okay, for the x value, I put a 0.
You have to leave it in a fraction.
Yes, definitely leave it as a fraction. You have to. Now, for the x-intercept, I'm going to let the numerator equal 0. Okay, so if I let the numerator equal to 0, then that's just going to give me x equals negative 1. Okay, this is my x-intercept. So I will put it as my x value, and then y will be 0. All right, so that is it for number 4. So this was my x-intercept. This was my y-intercept, by the way. Any questions on number 4? Okay. Okay, so picking up here with number 5. Again, I like to do the horizontal asymptote first. What's the horizontal asymptote going to be on this problem? Ah, see, it was a trick question, and you're not fooled. You won't have a horizontal asymptote if the top degree is higher than the bottom. So under horizontal asymptote, you're going to put none. Okay, that was my horizontal asymptote column, so we put none. But that means maybe we have a slant asymptote. When do we have a slant asymptote? So I'm sorry, I missed that. When do we have a slant asymptote?
When the degree of the numerator is 1 higher than the
Yes, when the degree of the numerator is 1 higher than the denominator. So that's what's happening right now. So yes, we will have a slant asymptote.
Wait, what did you say? When you have the degree?
If the degree of the numerator is 1 more than the denominator. Okay? So, I know there will be a slant asymptote. How do I actually find the slant asymptote, though?
You can do factors, make it simpler for you.
Yeah, let's do division. Let's do synthetic division. Okay? I'm going to go ahead and just do it right here in this spot and just erase it. So let's just do synthetic division. Okay? What if it was like problem number 6? Could I do synthetic division on number 6? No, because it's squared. For that one, I'll have to do long division. But when it's just x plus 4, let's go synthetic with it. So what goes in the little box? Negative 4 goes in the little box. And then, so the coefficients, 1, 2, negative 3. Okay. All right, so I bring this down. So I have 1, and that's negative 4, and that's negative 2, and that's 8, and that's 5. So looking at the 1 and the negative 2, what is my slant asymptote? X minus 2. Y equals. Thank you, my brother.
No, why is it x minus 2?
All right, let me go back.
Oh, right.
So slant asymptote, y equals x minus 2.
So you totally discard like 5.
Yeah, the remainder has nothing to do with it, okay? So we just basically put that x back in there, put a y equals in front of it.
What if it wasn't the 1? What if it was...
All right, so now we have to do the vertical asymptote and any holes. Let's see if anything cancels by factoring the numerator out. How does this factor down, you guys? X minus 1, x plus 3. All right, correct. Okay. Does anything cancel out? Nothing cancels out, so that means there won't be any holes. So holes, none. All right, now the vertical asymptote I'm going to get by setting the denominator equal to 0. So that means the vertical asymptote is x equals -4. Okay, so no holes. So time for the domain. We have only just the one vertical asymptote at -4. So that's going to give us the domain right there. So remember, just think of it this way. Here we have -4, and because of vertical asymptote, that's going to be a break in the domain. So that means we're going to have this part over here on the left, and then we'll have the part on the right. So domain. All right, so give it to me. Go. Negative infinity to -4. Union. -4 to infinity. Okay, you don't even need a graph to do it. Okay, you just need holes. Holes count 2. Breaking it up, all right? Holes count 2. Holes and vertical asymptotes are all you need. Now, y-intercept. To get the y-intercept, we let x equal 0. So that's always the easiest one. Okay, so if I let x equal 0, then that means this is gone, and this is gone, and this is gone. All right? All we have are the constants. So -3/4 will be the y-intercept. Okay, and because it is the y-intercept, I let it be the y value. So -3/4. The x value will be 0. To find the x-intercept, I'm going to set the numerator equal to 0. Okay, now look at the numerator in factored form. Okay, if I set these two equal to 0, you can tell what I'm going to get right now. All right, from x minus 1, I'm going to get +1. Okay, and from x plus 3, I'm going to get -3. So +1, -3. Now these are x-intercepts, okay? So I'm going to put them for the x value. So +1 and -3 for the x values because they're x-intercepts. The y values that go with them will be 0. Okay, so that's it for number 4, 5. Okay, any questions about number 5? Just scanning across it one more time. Okay? All right, so for number 6, once again, I like to look at the horizontal asymptote first. So what will the horizontal asymptote be? Say it again. None. There will be none, all right? The top degree is higher, okay? So there won't be any horizontal asymptote. Oh, shucks. Somebody said there will be a slant asymptote. How do you know, my brother?
Because the degree is one higher than the one on the bottom.
Yeah, if the numerator degree is 1 higher, that's when we will have a slant asymptote. So we will definitely have a slant asymptote. How do I go about finding it, though? Well, no, that's how we find like holes and stuff. Long division. We'll have to do long division this time. Okay, so I'm going to have to cut and paste this. Okay, so we have to do this long division. First, we ask ourselves, x squared times what will give us x to the third power? What's the answer there? X. And I like to line that up in the x column over here. Once you have that, do the distributive property with it. Take that x and distribute, like bam, kabam. X times x squared is, of course, x to the third power like we want it. X times -1 is -x. Okay, that lines up with the 2x, okay? What do I do now? You got to change the signs to make it to subtract. So that'll be minus x to the third power and plus x. Okay? So that's going to give me, bring this down, so I have -3x squared, and this makes plus 3x, and then minus 6. And then you start over. And ask yourself, x squared times what will make negative 3x squared. Obviously, what's the answer? Negative 3. All right, and I could continue on with the division, but I don't need to because we already have our slant asymptote is right here. So our slant asymptote is going to be y equals x minus 3. Kabam. That's it. Okay. So y equals x minus 3. And don't forget the y equals part. It's very important. All right. Now, what about the vertical asymptotes and holes? Okay. Let me come back to this again. Okay. To find out if there are any holes or not, we need to factor and see if anything cancels. So I'm looking at the numerator. I'm thinking grouping. Okay. If looking at those first two terms up there, okay, looking at these two right here, what's the GCF? X squared, right? So if I bring out that x squared,
Vertical asymptote and the whole.
it'll be for both. We need to see if there are any holes, because if anything cancels out, that means it won't be around to be a vertical asymptote. Okay. So that's going to leave behind x minus 3. Now, looking at the second pair, okay, what's the GCF there? 2. So I pull out that plus 2. Okay, and that's going to leave behind x minus 3. All right, that means grouping is working because I have x minus 3 twice. So I'm going to take that x minus 3, pull it off to the side. Okay, and then that's going to leave me with x squared plus 2. Now, will this factor any further?
This,
Like the x squared plus 2, does that factor more?
no.
No. Okay, so that's my numerator. So that's all done. That's my new numerator. Now my denominator, does this factor?
Yes.
Sure, that's the difference of two squares. How does it factor down?
X plus 1, x minus 1.
Correct. X plus 1 times x minus 1. All right. If anything cancels out, then I'm going to have holes. Does anything cancel out? No, everything's all different. So there won't be any holes. All right, so under holes, I'm just going to put none. Okay. Now, as far as the vertical asymptotes, that means both of these factors in the denominator are going to deliver a vertical asymptote. Okay? So I'm going to get vertical asymptotes from both of these. So that's why my vertical asymptotes are going to be x equals negative 1 and x equals positive 1. Okay? Any questions so far? So it's time for the domain. Yay! We should be able to do the domain just from the vertical asymptotes. Negative 1 and positive 1. Okay, so let me make a little number line to guide my eye. So we have asymptotes at negative 1 and positive 1. So that's like breaks in the graph here and here. All right, so I'm going to have 3 parts to my domain. Negative infinity to negative 1, union, negative 1 to positive 1, union, 1 to infinity. All right, does everyone understand that? See how we don't need a graph to do it? All right, if we ever had a hole, holes count too as far as breaking up the number line. Okay, now we need a y-intercept and x-intercept. To find the y-intercept, we let x equal 0. Okay, you should be able to do this in your head. James, imagine that I let all these x's be 0. Can you tell me what I would have?
Negative 6.
That's close. What would I have in the denominator?
Negative 1.
So what's negative 6 over negative 1?
6.
6. Positive 6, okay? If I let all my x's be 0, that means all of this would be gone. And this too. So I would just have the constants. Negative 6 over negative 1, which is positive 6. So this is my x-intercept. No. This is my y-intercept. So I'm going to let my y value be 6. X value is 0. So that's my y-intercept. For my x-intercept, I'm going to set the numerator equal to 0. All right? It's easiest to look at it on the black screen here, where we have our factored form. Okay? So if I want to find my x-intercepts, I need to set the numerator equal to 0. So I'm going to go x minus 3 equals 0, and I'm going to go x squared plus 2 equals 0. What's the yellow one going to be, obviously?
3.
Okay, yeah, the yellow one's going to give me x equals 3. What about the pink one?
It would be,
Plus negative imaginary.
Imaginary, right? If I subtract 2 from both sides, that gives me x squared equals negative 2. I don't even really have to keep going with this. If you can just look at it and ask yourself, can you square something and get a negative number?
no.
No, that's why it's imaginary. I mean, if I kept going, I would get x equals plus or minus I radical 2. Okay, you cannot have an imaginary x-intercept. Okay, so this is extraneous. All right, so we only have one x-intercept. It's at 3. Okay, so because I'm talking x-intercept, I'm going to put that 3 for the x value. So 3 comma 0. All right, that is it for number 6. And that's going to be the end of this video. We'll pick up with the next video, problem number 7, where we get to do a whole graph.
Yeah.
Bye.
All right, you guys want to say anything, class?
Bye.
Sound?
My Instagram.
Instagram. Go ahead. Use your chance. Anybody wanted to
Can I use the
shout out? Restroom shout out. What?